Hi guys, Joshua with Lisle here, designer blacksmith, and hopefully a very exciting episode for you. Now it's been a long time since my last video of doing the barbecue forge, which was a great load of fun, but since then my camera had broken and I've got it back now, but I've been busy and life had just taken over, so that's why it's been quiet for so long. So let me show you the project that I've done. Now I'm sorry, it's not going to be a cool time lapse or sped up video like the other ones that I do. You've literally just taken seeing the last stage where I'm about to get this piece finished. But there's some really interesting metalwork in this that hopefully you'll enjoy. So come on, let's have a little look. This is a bell frame for Salisbury Cathedral. So really pleased to have been able to do something for a cathedral. You know, people who pay for really top quality ironwork. So the idea with this is it's actually a tubular bell, which I will show you my CAD design. So there's a tubular bell. This was created by Quinton Cowan, really talented brass worker. And this frame is to support the bell, so they're going to gong it every hour on the hour for prayer time within the cathedral. But they needed it to be transportable, so I've actually got some really neat little mechanisms in this that you can't see at the moment. But this moves around with some wheels. Now you probably can't see the wheels, because that's on purpose. They wanted a nice skeletal structure that was very clean line and fitting, and there are wheels on it, but when you're gonging the bell, you don't want it to be rocking around. So there are actually pins and lever systems here, so when you're moving it around, the pins aren't attached at the moment, I do apologise. These levers go up, these lift the pins up, and so you can push the bell around. And what happens is you can push these levers down, they lock in place, create this nice clean line shape, and the pins touch the floor, lifting the structure off the floor, and it then becomes rigid, you won't be able to move it. So I've got a little, I've detached one of the parts just here. So hopefully you can see this okay. There we are. So this is what's inside. Now I've got a stainless steel pin that's spring loaded on here. So this is pushing the pin down as the lever goes up. It then clicks up into place, holding the lever in place, and the pin has gone up off the floor, which enables you to move it around. And then to just, it's rounded on the top, you just push the lever down, and it disengages and pushes the bell frame structure back up. And like they say, with a long enough lever, you can actually move the world. And I've created this nice little groove joint, which is two pieces welded together on a curve, a bit like angle iron, and you can get your fingers in there and not get them trapped underneath, as you can see down here. So let me show you the wheels. Now this is one of my favourite parts. So this is the wheel that I'm talking about. This is called an Omni wheel. Made by Rotocaster, this one. It's an Australian company. I had to buy them and get them from Australia, but they're fantastic. Because the idea is, and here we go, for demonstration purposes, this wheel, obviously it can spin in this direction, but it's also got these other wheels on top that go in opposite directions. So it'll actually go this way as well. And if you go at in a diagonal line, it kind of spins and does this at the same time. It's such a clever little wheel, but what it means is caster wheels, they pivot and have a structured wheel, and it takes up quite a large amount of space. Or this, you just need to have one fixed point and it will move in all directions. Which the idea is, I can actually fit them all in this channel section around here. So I'm going to bring the bell frame back down and we'll have a look, shall we? Let's have a closer look. So here you can see what I mean by the wheels. We turn this way and turn that way as well. And so there are 8 within this channel, and here are the parts where the pins come through. So the springs are loaded inside there, the pins are pushed up, and as you're moving the lever, those pins go up and down. I put this little pin there to kind of centre it into place, because I wanted it to be a little bit loose, so you know, when applying the finishes it doesn't get caked up and it still works properly. So let's have a look at some of the structure on how I've made this. This was 2 rings that I had rolled and by another company, and then kind of fix them together myself. The top ring, so this is 3 parts to be specific. So you've got a flat ring here, well, you know, like a wheel ring, if you like, a wheel ring here, and a flat ring here. So this one actually had laser cut to be absolutely precise on the measurement, because it needed to be a perfect circle and all look right. So doing that by hand and eye, even with a template, might have been very difficult. These parts here, the arms, I created a design on CAD. So this whole structure I designed on CAD. In particular Google SketchUp, I really recommend that. You can download it for free. I've got the professional suite, so I can do extra things professionally. So you pay money for that one, but you can do quite a lot on the free one to learn how to do it, so I recommend that if you're interested in CAD. So I'm quite prepared for this video, as you can see. But what I was able to do on CAD was to develop these stencils, if you like, blanks. So you can see there, drew it on the table, and then that's been my datum for forging those pieces out. So these were forged, and so once I'd created the flat profile, I was then able to then curve it in this way. So first of all, I forged out and curved it that way, flat. Then I curved it this way to match the circle. And because I'd done it on the CAD, the design had already calculated the exact amount of material that I needed. So when fitting it, it was all pretty much exact. Although it's been slightly variating just because it's been done by hand. So the next part is the actual archway itself. So this, as you can see, is 2 pieces together forming a T-section. So there's a horizontal piece and then a vertical piece. This gives it obviously superior strength. What I wanted to do as a blacksmith, because this is kind of more fabricational work, even though this is actually riveted together. You might not be able to see it because I've ground all the rivets back, but here, there's a telltale sign. So that is a rivet, as in I've drilled through, I've countersunk the ends, there's a solid bar going through, and I've heated at both ends and squashed them together, and the heat contracts, pulling the whole thing really tightly and rigidly. It's a solid rivet, but it's been ground down flush. So you won't be able to see the join. Which is a really neat approach, and there's obviously several throughout the whole ring. But what I wanted to do originally was to forge it all. You know, have as much blacksmithing. So the ring, as you can see, is completely fabricated. So this is all arc welded together with several runs and then all ground back. These were forged. The arms were, as I said. The archway obviously isn't forged, and I have welded it at the top because that was the best way, as in mechanically welded it rather than traditionally forged or traditionally welded. But I'm going to show you the tool that I developed, because I wanted to make it out of solid section originally. So if I can find my tool, just a moment. So let me show you the original die that I made for forging out the sections. So as you can see by the negative space, that is the T-section that I wanted. So I had nice curved and rounded edges, and the idea was I would forge in this much larger material into the die, and as I moved the material backwards and forwards, I would create the T-section that I wanted. So this is what I ended up with as a test piece, and as you can see, it's not it's not neat enough, and it didn't actually fill the die fully. There's major gaps and stuff, so it wasn't to the dimensions that I wanted, and like everything I do, I want to make it as close to the drawing as possible. So the problem I had, and I know what's wrong with this, this is the same size as the pallets on my power hammer. So you can see that section there is pretty much exactly the same. And that's what caused the problem. Realistically, this die should be almost, I would say, 3 times the size. So equal amount of space there, and all of that to be the die section that needed to be forged, with this, the intent that the top die would be forging. The problem, one of the biggest problems I had is that because of the nature of the top being forged more than the bottom section, it wanted to do a big curve, a big arch, because you're stretching the top material, the underneath material is remaining the same. So it tries to do this arc, so you're constantly trying to straighten it, and as a consequence, you're just galling the metal as you're trying to do that. Another problem is that the material I chose, although I calculated would fit and fill the die specifically, it was not known how much these curves would stretch it this way and that way. So I found that I needed much bigger material to fill the die with, and was simply getting very, very expensive, and it was no longer cost effective to do it in the forge way. And it would have been incredibly difficult actually to have kept it all straight afterwards. Ideally, if you're going to forge section, you need a rolling mill. But for short pieces, you know, it's fine for doing it in the power hammer like this, although for doing that size section I needed a much larger power hammer. So I've explored the limitations of this one. This is a Lisle SM50, a 100 weight. It's a beautiful power hammer, I really enjoy using it, and I probably will do a video about my equipment after this one. But it wasn't working, so then I quickly adapted and just found a much cleaner, easier solution, and that was just to rivet these 2 pieces together. I did think to weld it, but again, welding causes lots of heat distortion and everything, and actually looking at traditional ironwork on, well, basically the ironwork that they have in the cathedral, you'll find lots of sections like this, which is what this is based on, and that is all riveted together, and you don't see the rivets. It's all very clean and very nice. So that was the intention of that. So let's leave the piece back up, and I'll show you a little bit more. So the bell itself is going to be, as you can see, there's a cord that comes through here. Apparently it's Kevlar paracord, which is the chosen material that would be best for the bell, and it's resonating and all of that. So how have I fixed those on? So I'll show you what I've made for that. So quite simply, I've made these tiny little plugs, if you like. So you see there's a little loop. So the idea is the cord gets passed through this hole, comes out the other side, is attached to this little plug, and then is simply dropped in place just there. And you can see how clean line that is now. You can barely see it, especially when it's got its finishes on. That will be pretty much invisible. And so the cord will be passed through here to the bell and back to this one. And I will have shown you a CAD design, but these were kind of as my working drawing I was going to. So this is about to get finished, and when I talk about finishes, I normally get things hot dip galvanized. Now because of this structure, it's all very kind of although it's T-section, it's reinforced. Under a lot of heat, this section could essentially warp and buckle under if it's heated. And when it's heated in the hot metal of zinc, you know, it's at least 400 degrees C, you know, that gives every single chance of it buckling. Also, these very precision made, I did these all myself with cutting discs, drills and files. You know, this all has a chance of getting absolutely caked in molten zinc and is extremely hard to gouge out. Now, I always recommend doing galvanised work because I want my work to last indefinitely. You know, I always want to do the highest quality metalwork I can do, and for it to last as long as possible. Because when I die, you know, my stuff will be living on longer, and will continue to inspire and get other people into metalwork, hopefully. And so everything I want to make sure it lasts for an incredibly long time and free from maintenance, and that's exactly what galvanisation does. And there are other finishes that you can put on top to make it look as though it's back to being pure metal again. But in this case, I'm not going to do that because of the huge risks of warping under the immense heat that galvanising brings. So instead, I'm getting it shot blasted to take all of this back to bare metal, and then I'm going to use this stuff. UPOL acid etching. So this is an etch primer, and the idea is this actually eats into the metal and really keys in. You know, it's going to be super duper strong. And then I'm using on top of that a paint called Galvafroid, which is 90% zinc. The idea is it will give me the exact look of hot-dip galvanization. It won't be as good as hot-dip galvanization because hot-dip galvanizing, the zinc actually alloys with the surface, and it's that gives it its superior protection. And also you get some microns of pure solidified zinc as well, which is also great protection. So you're talking about, you know, 50 years outside, you know, over 100 years plus in any other condition, which is fantastic. So the Galvafroid paint is going to give me the same look, similar quality in protection, just not quite as good. But it means that there is absolutely no risk to warping or damage, you know, and I can keep all of these joints absolutely freed up. So then on top of that, I'll be putting my own secret formula of graphite and wax, and it will look pretty much exactly the same. You won't be able to tell the difference. For an example of the finish that I'm talking about, I have my one of my original horse sculptures here, Equus, who is also going to get refinished, and this is going to be hot-dip galvanized, believe it or not. But you can see this lovely finish I'm talking about. That this kind of black, natural grain finish is, you know, it's not paint. You can see all the little hammer marks. That's the finish that I'm looking for with most of my stuff, just because it's so natural to the material, and it just looks beautiful, in my opinion. So that's the same finish that I'm looking for. Okay, so I'm really, I hope you have got a lot out of what I've just showed you. I'm really sorry that I wasn't able to do more on all the different techniques and how I made it all and all that kind of thing. Please leave comments below. If there are things that you're like, Josh, how did you do that? I will explain it as best I can, and if enough of you are saying, you know, how did you do it, then I'll do another video on it. So I'm going to dismantle this now and take it to the finishers, get it all shot blasted, and then in another video I'll be showing you the finished artifact and delivering to the cathedral, and hopefully there'll be a really nice ceremony and it'll all look fantastic and it'll all be working and it'll be brilliant. But I'll also want to say that there's another channel that I'm creating. So this channel is going to be pure blacksmithing, metalwork, engineering and all things good, and it's going to be free from any of the kind of stuff. But I'm more than that in a little way. You know, I've got loads of stuff that I'm really interested in and really excited about, and would love to discuss more, you know, as an actual kind of, rather than just me doing a bit of teaching and all this, you know, an actual discussional kind of thing I think would be really good. And that's all going to be things from like religion and politics to DIY and home inventing and gardening and all these kind of things that I am so love and passionate about. As well as this metalwork, this channel is going to be pure metalwork, but the other channel, which will be in the description below, will be everything outside of that, and it'll be completely random. So if you're interested in that, then please visit that channel. But if you're just purely interested in metalwork and how things go, you know, feel free to talk to me more. And I'm also doing another video within this on all my equipment. So all these different pieces of kit, like my power hammer, gas forge, coke forge, belts, sanders, angle grinders, drill presses, all these different things. I'll be doing my little review on the brands and stuff that I've got. What kit I would eventually like to buy, you know, my ideal solution. Stuff that I bought and I really wish I didn't, you know, there's always that kind of a thing as well. Yeah, you might find that interesting. So please give this a like if you like it, that encourages me to make more videos for you guys. And please do comment below anything you're interested in. I love having a nice discussion and being part of the metalworking community. Right, take care and happy forging a life worth living, and catch you guys later. Bye bye.